Algebra Word Problems, number 36A. Write, solve equations for mixtures, two variables. So we're solving for x and y now, and making a table is the easiest way to solve mixture problems. Solution mixture problems deal with percentages of chemicals which are mixed together to create a mixture. Useful in chemistry, they use the term solution, concentration, which is the strength, and may refer to concentration as a percent solution of the main ingredient. So think of making French toast. You got 2 eggs, a third cup of milk. Well, you mix those in a bowl and it makes a solution, and it's a delicious one. I'm going to add a little cinnamon to make it taste even better. So we've solved mixture problems for one variable in my previous videos. Now we're going to use more than one variable and a system of equations. So here's the first word problem. How many ounces, OZ is short for ounces, each of a 5% hydrochloric acid and a 20% hydrochloric acid solution must be mixed together to get 10 ounces of solution that is 12.5% hydrochloric acid. So we think, all right, well, a 5% acid solution means it's 95% of something else. So it's kind of weak, isn't it? That's a weak solution. And 20% is 80% of something else, and it's stronger than the 5%, so it's a little stronger. 12.5% is in between them, isn't it? It's kind of a middle solution, all right? And that's what we're trying to create, and we know there's going to be 10 ounces. So we're going to let x equal the ounces of 5%, because that's what we need to find. See, it says how many ounces. That's what we're looking for, is how many ounces. So x is going to equal the ounces of 5%, and y is going to equal the ounces of 20%. And we know if we add them together, it's going to be 12.5% and 10 ounces, okay? So I make a table, but my table looks different than other teachers. And I call my table a PQP table. And this is my little invention. The PQP stands for the percent, the quantity, and the pure. The percent was given to us in the word problem. 5%, 20%. We add these two solutions together, the weak one and the strong one. It's going to create that middle one at 12.5%. And we assigned x and y as the quantities, the ounces of 5% and the ounces of 20%. And we know that the 12.5% solution is going to have 10 ounces. See? To get the last line for the pure, the ounces of pure, all we need to do is multiply straight down. See? If we multiply each of these columns straight down, it's going to give us this. All right? So look, here's the PQP coming down, and if we multiply all of these three coming down like this, this last one ends up becoming our second equation. All right? So let's take a look at this. 5 times x would be 5x, but because it's a percentage, we write it as 0.05, so we have 0.05x. 20 times y is 20y, but because it's a percentage, we write 0.20, so we have 0.20y. And 12.5% is actually 0.125, so we have 0.125 times 10, and that's our second equation. We have our first equation given here in the Q row, and in the pure row, the last P, it gives us our second equation. See? Do you see how we did that? Just remember, multiply down, multiply down, multiply down, and that gives us equation number 2. All right? So let's see what we've got here. We moved up here to get more room. Here's equation number 1, x plus y equals 10, and equation number 2. 0.05x plus 0.20y equals 0.125 times 10. So the first thing we need to do is remove the parentheses from the right side of equation 2 by multiplying 0.125 by 10. So we do this multiplication right here, and we end up with 1.25 because it moved the decimal place 1 point over behind the 1. Now we need to remove the decimals from equation 2 by multiplying both sides of the equal sign by 100. So we multiply this side of the equal sign by 100, and we multiply this side of the equal sign by 100. So remember, it's like a scale. Our equations are like a scale, and we want them to balance. Whatever we do to one side, we have to do to the other side, okay? So multiplying it by 100 is going to move the decimal place from in front of the 0 to behind the 5. And it's going to move from in front of the 2 to behind the 0. And it's going to move in front of the 2 to behind the 5. See? And now here's our new equation 2. This equation 2 is now this equation 2. 5x plus 20y equals 125. Now, we observe that in equation 2, it starts with a 5x. And to remove x and isolate y to solve for y, we're going to multiply both sides of the equal sign in equation 1 by negative 5. So this is planning ahead. If we multiply this by a negative 5, this x is going to become negative 5x. Our next step is to subtract the equations from each other, and if this negative 5x is underneath this 5x, that's going to eliminate it, isn't it? We're going to be able to solve for y. So that's what we do. We multiply both sides of this equation by negative 5 to plan ahead. You know, it's like playing chess. You think ahead. And now, equation 1 becomes negative 5x plus a negative 5y, and it's going to equal negative 50. All right? So now we subtract equation 1 from equation 2. And the positive 5x here minus the negative 5x, well, that just gets rid of that for us, doesn't it? And now we have 20y take away 5y, that gives us 15y. And 125 minus 50 gives us 75. Well, 15 times 5 is 75, so we know that this equals 5. And this turned into a 1, right? Because when a numerator and denominator are the same, it turns into 1. We don't put a 1 in front of a variable, do we? So now we have y equals 5. Now that we know that y equals 5, we can plug that y value into the original equation 1. Remember the original equation 1? X plus y equals 10. So this becomes a 0 pair, and it's gone. And now we know that x equals 5. X equals 5 and y equals 5. And now we know our solutions, don't we? This is 5 ounces, and that's 5 ounces. And added together, they make 10. See? Now, these are very, very difficult to do because they have so many steps. The steps aren't hard. It's a bunch of very menial, easy steps. It's just hard to remember all the steps to do. So here's my advice. Find a mixture problem like this that you can copy and write down every single step just like I did and put it on a page of your spiral. And that way in the future, you'll be able to reflect back to it as a template, as instructions on how to do these solutions until you become more familiar with them. Just make sure that you write it neatly so in the future you can read your writing instead of saying, oh my gosh, what did this say? What was I supposed to do? Be extremely thorough in your instructions to yourself, and that way, when you have to do a solution problem again, you'll be able to reflect back to that page and say, that's right, that's what you do. I remember. Okay, so that's my best advice to you. All right, we're going to do another one, and I hope I'll see you there. Bye.